In this section, we're going to talk about the relationship between equations and graphs, how when necessary we can solve equations graphically. And even when we have algebraic methods, it gives us another option we can rely on. So, first of all, I want to remind you about intercepts. Solutions to equations are very closely related to x-intercepts, but the intercept is where the graph intersects a particular axis, so you can have x-intercepts and y-intercepts. And at the intercept, the other coordinate is 0. So at the x-intercept, you have a certain x-coordinate, the y-coordinate is 0. At the y-intercept, the x-coordinate is 0. In general, for functions, it's a lot easier to find y-intercepts because you can solve for y and then plug in x equals 0 and you just evaluate the function. But in order to find x-intercepts, you have to solve an equation, which can be very challenging. We talk about all of the nice algebraic ways we can do that in this class, but sometimes you have to rely on numerical methods, which is something we'll look at in this section. So here's just some notation about the fact the intercept is actually a point. Okay, it's a point where the y-coordinate is 0 if we're talking about the x-intercept, and so technically we should say something like the x-intercept is the point 2, 0. Sometimes we just say the intercept is x equal 2, okay, because we know that the other coordinate is 0. So as it says here, unless necessary to make the distinction, we could use either way of doing that. Okay, and it's possible that a graph can have any number of x-intercepts from 0 up to any possible number. And here's some pictures. Okay, I will note the first two are functions of x. They would pass the vertical line test. The second two are not. Functions at most could have one y-intercept because of the vertical line test, right? We have one y-intercept on the first two pictures. This one has no y-intercepts because it's a circle that doesn't hit the axis. It's not a function either. This one hits the y-axis twice, has two y-intercepts, but it's not a function. Okay, x-intercepts, functions could have any number. Okay, so here's a polynomial graph that has 3 x-intercepts. Here's one that doesn't have any. Here's one that doesn't have any. Here's one that has 1. Okay, so in terms of the x-intercepts, which is what we're really going to focus in on because that's how we get our solutions to our equations, you can have any number depending on the type of equation. Okay. So let's do one by hand first. Find the x and y intercepts for this linear function 5x minus 3y equals 15. So you just set the other variable equal to 0. If we want the x-intercepts, we set y equal to 0, which is pretty quick with this equation. Okay. We get 5x minus 3 times 0 equals 15. Well, the 3 times 0 is 0, so we just get 5x equals 15, and we can divide by 5, and we get x equals 3 as our x-intercept. It's going to be pretty similar work for the y-intercept with this type of equation. We set x equal to 0, so we have 5 times 0 minus 3y equals 15, which gives you, oops, lost my negative sign there. It should give me negative 3y equals 15, and the y should be negative 5. Okay, so fix that. Put the negative signs on there. Okay, easy mistake. Always check your signs. I almost lost my negative sign there. But we have an x-intercept at x equals 0 and a y-intercept at y equals negative 5. So to find intercepts, you set the other variable equal to 0 and then solve. So next, if we want to start talking about these things graphically, there is a connection between solving equations and finding x-intercepts. Okay? We can always take any equation and rewrite it by setting everything equal to 0. So if we want to solve an equation of x equal to 0, we're looking for the x-intercepts. We also say that we're looking for the zeros of that function or the solutions of the equation. So I've mentioned this in previous sections. Those are all sort of synonyms for each other. Finding the x-intercepts, finding the 0 of that function, finding the solution of setting that function equal to 0, those are all doing the same thing. Okay? So before we find some, let's first see what does it mean to have a 0 of a function. Again, it means that you plug the values in and you get 0, so this is pretty quick just to check here numerically. So we've got f of x equals x squared minus 3x minus 10, which you could solve by factoring, but we have the solutions given to us, we just want to verify them here. So we plug 5 in, we're going to get 5 squared is 25 minus 3 times 5 is 15 minus 10. Well, that'd be 25 minus 25, which is 0, so 5 is a 0. And so is negative 2. If we look at negative 2 squared minus 3 times negative 2 minus 10, we get 4 plus 6 minus 10, which would be 10 minus 10, or 0.